So moving on to the next section of this class, which will be called What are types of data? So there are a couple different types of data that can be understood in R. First of all, we have numeric data that are numbers, and then we can also have character data, which can be symbols or letters. So let's start off by working with numeric and integer data. So I'll write a comment to myself, which will entitle this section of the code called numeric and integer data. So let's say I want to understand how R is interpreting the object called year. So I will, in order to do that, I'm going to use the class function. So first of all, I'll type out the word class, and then we can see that R understands that there's a function called class. Class stands for classification. I can click the class function, and then we can see that R will place an open and a closed parentheses. So the function is labeled by class, and then we have the object which will be interpreted through our function within the parentheses. So let's say I want to find the classification of year. So I will type class and then year within the parentheses, and if I run that line of code, we can see that R is interpreting the object called year as a numeric variable, which is convenient because year is a numeric variable called signifying the number 2022. But let's say I want to understand how R is interpreting the object called Dylan's age. So again, I can use the classification function and I can type Dylan's age. Again, R already understands that I want Dylan's age. I can click Dylan's age. And then if I hold Control and Enter, we can see that R is interpreting Dylan's age as a numeric variable, which is convenient because Dylan's age is a numeric variable. It's equal to 30.2. So let's say I wanted to convert Dylan's age, not from a numeric variable to an integer variable. So in order to do that, I can type Dylan's age, and then I can set it equal to an integer by using the as.integer function. So there's a function called as.integer, which converts numeric variables to integers. So I'm going to type as.integer, and then I'm going to type in Dylan's age. So we originally set Dylan's age to 30.2, but now we're going to convert it to an integer where we're going to, again, type Dylan's age, Dylan's.age. We're going to rewrite over the original 30.2, and hopefully it will turn Dylan's age into an integer. So if I run that line of code and then I type Dylan's age, we can see that Dylan's age is now equal to 30. So it actually rounded down for us because we wanted to change that numeric variable that had a decimal place in it into a whole number or an integer. So it rounded down from 30.2 all the way to 30, which is convenient. So now if I look at the classification of Dylan's age, we can see that R is no longer interpreting Dylan's age as a numeric variable. It's interpreting it as an integer. So it's a whole number now. So it looks like we've made pretty good progress. So I think it'd be probably an appropriate time to save our R script. So in order to save an R script in RStudio, I'm going to click File. I'm going to move down to Save As. And then we can see that we have a save window opened up, and I'm going to save this as Class 1, Florida Data Science Academy, FDSA, and I click Save, and then our script changes from untitled to Class 1 FDSA. So that's great, and now I'd like to move on to the next section in our code, which is going to be entitled Characters and Vectors. So previously, we've been working with numeric and integer data, but we can also work with characters, which are letters and phrases, and vectors, which are objects that store multiple different elements as a single object. So let's start off by creating an object called name. We'll set it equal to a character called Dylan. So as you probably know, my name is Dylan, and this character element is being designated in green text, signified by quotation marks. So if you want to create a character element in R, always use quotations. You can either use a single quotation or a double quotation, and that will turn your text green. And that signifies that R is understanding this as a character element. So if I run line 32, we see that in our R environment, there's an object called name, and it's set equal to the phrase Dylan. And if I wanted to look at the classification of name, we see that the object called name is being understood as a character element. So that's what we intended. So we're on the right track. So let's say I wanted to rewrite over the object called name. So I'm going to create a new object called name, which will write over the previous object that's equates to Dylan. But I want to set it to equal to all of the letters in the name Dylan. So in order to combine multiple different elements to be stored as one unique vector, I'm going to use the concatenate function, which is signified by a C and then open and close brackets. So we have this C concatenate function, and I'm going to type all of the letters of the name Dylan. So we have a D, a Y, an L, an A, as well as an N. So we have 5 different elements here. Each one of them are signified uniquely within quotations, and then they're all spaced with commas. So if I run that line of code, and then we take a look at the object called name, we see that name is equal to 5 different elements, D, Y, L, A, and N. We can also look in our environment, and we can tell that name is a character vector signified by the C, H, and R, standing for character. And then vectors in R are signified by brackets. So this one means that we have one vector that's constituted by 5 different elements, D, Y, L, A, and N. And let's say if I wanted to look at the classification of name, we note that R is interpreting the object called name as a character vector. We can also look at the structure of name. So we use the str function. That's somewhat similar to, well, actually not too, well, it's relatively similar to the classification function, but it gives us a little bit more information, and you'll see here. So as you can tell, structure does demonstrate what type of data type it is. So name is a character element, and it's actually a vector because we have 5 separate elements that are being stored as one unique object. So classification gives you the general understanding of what kind of data type it is, but structure gives the data type as well as lets you look a little bit further under the hood and gives you a little bit more information. So that's our section on character vectors, but let's work with numeric vectors. So we've worked with numeric variables, but we haven't stored them as unique vectors. So we'll start off by creating an element called years. We had an element previously that was year that was set equal to 2022, but now we want an object called years that is equal to many different years. So we're going to have years is going to be equal to all of the years that I've been alive. So I was born in 1992, and the current year is 2022. So if we want to create a vector that's equal to all of the years from 1992 to 2022, we type the first year and then separated by a colon, and then we put the last year in our sequence. So if we run that line, we see an object opens up in our environment. It looks like we have a lot of different years, but to look at them in more detail, I'll type out years, and we find that years is actually equal to each unique integer from 1992 all the way to 2022, and that's exactly what I intended. These are all of the years that I've been alive. R did a good job at finding that answer. So, but let's say I wanted to create an object called years that isn't equal to every year that I've been alive. Let's say I just want to have years be equal to specific years that would be relevant to a given data analysis. So let's say I'll create an object called years. I will set it equal to, let's say I just want my birth year, 1992, the year 2000, and then the current year, 2022. So again, we're using this concatenate function, and then we have three separate elements that are separated by commas. And unlike the character section, I'm not separating these elements by with quotations because we don't want them to be understood as character elements. We want them to be understood as numeric variables. So we're not using quotations, but we are separating them by commas. And we can run that line, and then we can type out years. And we see that R has written over the previous object called the years, which is equal to all the integers from 1992 to 2022. Now we have a new object called years that's only equal to the three specific years that I wanted it to be equal to, which were 1992, 2000, and the year 2022. So that's just an example of how we create numeric vectors in R, but now I'd like to move on and create a new section, which will be called Working with Numeric Vectors. So it's not enough just to create numeric vectors. We actually have to do certain data analyses in order to create informative analytical insights. So let's say I'm a teacher at an elementary school, and I have 5 students in my class, and I'm just documenting all of the grades that were I'm documenting the grades that were in my class. So of maybe a previous test. So I'll create an object called the grades, and I'll use the concatenate function. And the grade, I have 5 students, and the grades that they got in this test were a 70, a 75, a 72, a 74, and an 80. So this object called grades will be equal to 5 separate, a vector of 5 numerical elements, and I'll run that. And then we can take a look at grades. And indeed, we have a vector constituted by 5 separate numerical elements. But let's say I wasn't too happy with the grades that my students got on this test, and maybe I implemented a new curriculum or a new study guide to help them out on the next test. So I'll create a new object called new grades. And let's say all of the students did much better on this test, and they got increase their grades by 5 percentage points. So let's say I wanted to increase, just add 5 percentage points to each one of the unique elements of the object called grades. So I'll do that by typing grades and simply adding 5. And if I run that line and then type out new grades, again, R already understands that there's an object called new grades, so I can just click enter and new grades pops up. And if I run that line, we see that R successfully added 5 percentage points to each one of the elements in grades. So a 70 is now a 75, a 75 is now an 80, and so on. So that's just a basic example of how we do some basic arithmetic and work with numeric vectors in R. But we can also do a little bit more complicated examples. Let's say I want to create an object called newer grades. So say I implemented another study guide or new curriculum, and I want to add 10%. I want to add 10% to the grades from the original assignment. So I'm going to type grades, and then I'm going to add 10% to each one of the previous grades. So I have the original object called grades, and then I'm adding 10% from their previous test. So
So I want them to increase their grades by 10%. And if I run that line, and then I type out newer grades, we see that R successfully added 10% to each one of the original objects called grades. So a 70 is now a 77. A 75 has increased all the way to an 82.5. The third grade was a 72. That's now a 79.2, and so on. So that's just another example of doing some basic arithmetic, a little bit more complicated than our original example, but still important.